everyone. This video is going to detail how to conduct an independent samples t-test on SPSS. In this scenario, we are going to assume that we designed a survey that assessed the stress of college students during finals week. And we wanted to see if there is a difference between males and females regarding their level of stress during finals week. So for the sake of time, I've gone ahead and entered all of the data that we'll assume that we collected from this example. And you'll see that there are two columns here. Now, if you remember, using an independent samples t-test is appropriate whenever we have one categorical variable whose groups are mutually exclusive and a continuous variable. Now, in this example, our categorical variable would be gender. Gender, we're going to be using male and female, which are going to be our mutually exclusive categories. In this example, you cannot be in both groups. You're either in one or the other. Now, you'll see that the way that this is entered, it's entered as 1 and 2 and not male and female. And the reason for that is that SPSS does not recognize text. It only understands numbers. So what you need to do is make sure that you have a little note or some kind of understanding of what these values correspond to. And then this is going to be important later. So make sure that you hold on to this information in the back of your mind. Moving on, our continuous variable is going to be the stress scores. So what did they score on the survey? And this can range anywhere from 1 to 15, higher levels indicating higher levels of stress. Now, before we get into analyzing our data, we need to make sure that our variables are set up appropriately. And we do this by going to the variable view at the bottom. And what you'll see are two rows that correspond to our different variables that we are analyzing. In the name column, I've gone ahead and named the variables. We have our gender variable and our stress variable. I recommend you guys name it something relatively short but easy enough to understand. The longer the name, the more confusing the output tends to be. And typically what we do from here is we want to make sure that every column is appropriate and formatted correctly before moving forward. Now with this particular variable with gender, we don't need to mess with any of the settings until we get to values. Once you get to values, you're going to want to press on the box and you're going to see this little ellipses open up to the side here. You're going to want to press on that and you will get a little dialog box that opens up like this. Now, we mentioned earlier that we inputted our categorical variables as 1 and 2, and this corresponds to being either male or female. And this dialog box is where we tell SPSS that information. So how we do that and how we enter the values and labels in is first you want to press this plus box. If you're using a different version, it may be add. Anyway, you want to find whatever the add option is on this dialog box. Press on it. And then we're going to use our values, which are going to be our numerical data. So we use 1. And this corresponds to the males in the study. There you go, with a value of 2. This is going to correspond to our females. So you want to make sure that you have kind of coded this data correctly as you are entering it in to make sure that every time a male participant popped up, you use the value of 1. Same thing with females. And once you kind of are sure that that happened, you can move on from that and kind of press OK. Again, continuing up along the row here, we are going to make our way to measure. Now with measure, it is kind of defaulted as a scale measure, and this is for continuous variables. Gender in this scenario is not a continuous variable, it's categorical. So you're going to want to press on that box. and scroll down to the nominal measure. Because there is no inherent order with gender, it is just two mutually exclusive categories. We are going to select the nominal measure. Now we are complete with the gender variable. We can move on to stress. And with stress, because it is a continuous variable, there is no need to mess with the values. And our measure would be scale. That would be appropriate for this variable. So nothing has to be done for our continuous variable. Now going back to data view, you can see the symbol has changed, indicating that we have labeled gender as a nominal level variable. And just kind of building on our knowledge in data view, it's important to understand what these further column represents, are going 1 through 20. This represents each participant in our study. So participant number 1 is going to be indicated by the top row here. Participant 1 was a male who scored a 12 on the stress test. Participant number 2 was a female that scored a 14. And we got so on and so forth until we end up seeing that we have about 20 participants in the study. We also want to make sure that there is no missing data, because that would definitely throw off the validity and a lot of the measurements of our study. So make sure that all of your data is completed and it matches exactly what is provided on the data collection sheet that you are pulling it from. Now moving from here, we can begin to analyze this data. And we do that by selecting Analyze here at the top. And then you're going to want to find Compare Means. And then from this Compare Means option, we're going to select our independent samples t-test. Now, how it is going to shoot out for y'all is that both variables will end up being in this left-hand box here. And then you're going to see two options for test variables and grouping variables. Now, our test variables, this is what we're testing for. This is essentially our dependent variable. This is what we're assessing to see if there's a difference between. In this example, and pretty much in all independent samples t-test, this is going to be our continuous variable, our stress variable. So we're going to want to move that over to the test variable box. And then we're going to take our categorical variable, our gender variable, and bring it to the grouping variable box. Now, what you'll see here is that we have gender and then a parentheses, 2 question marks, and parentheses. This is SPSS asking us what are the group values, what are the labels that are provided. So in order to help answer that question, we have to select on this Define Groups option. And we're going to use the values that we assigned our labels to earlier. So if you remember, the value of 1 corresponded to males, and that's going to be our group 1. So we'll make sure that we have used the values accordingly. And group 2 will be our second group, our females, which was corresponded with a value of 2. That's why I think it's very important just to use the values of 1 and 2 for this, because it auto-populates itself on SPSS, and it just makes the process a little less complicated. You continue from there, and you'll see that gender has populated with the 1 and the 2 in the parentheses. You can go ahead and uncheck the box for estimate effect sizes, and then you can continue. Now, as I switch my screen here, what you'll see is the output that we receive from SPSS. Now, there's quite a bit of information presented, but we're only interested in a bit of it. First, we're going to want to look at our descriptives, and this is going to be located at the first box provided. You're able to see we have our genders, our males and our females, and we see with the column associated right next to gender, we have our sample size. In this particular example, we had 11 males and 9 females. Males had a mean score of 11.5, we'll call it, on the stress test, and females had a mean score of 11.7, we'll round up, on the stress test. Now, keep in mind with this independent samples t-test, we are here to determine if there is a difference between the two means, a statistically significant difference between the two means. The eye test kind of shows us that there's probably not a significant difference between 11.45 and 11.66, but let's see what the rest of the output tells us. Now, moving down to the second box here, you'll see at first that we have two rows here. We have equal variances assumed and equal variances not assumed. Now, this is really important because we have to first identify which row we are going to be collecting our data from. And how we determine this is from this first significance value here. So if this first significance value under Levine's test for equality of variances is greater than 0.05, then we are going to use equal variances assumed. We would use the top row. But if this value is less than 0.05, we are going to use equal variances not assumed in this bottom row here. So by looking at the value provided, it is 0.046. This is less than 0.05. Therefore, we are going to use equal variances not assumed. We're going to use all of the data provided on the bottom row here. So you can see we'll have a t-score of negative 0.190. We have 13.461 degrees of freedom. And whenever we are interpreting the associated probability, trying to determine whether or not there is significance, we are going to look at this significance column. We're going to look at our two-sided P and be sure that we are using the equal variances not assumed value there at the bottom, which is 0.852, which is obviously greater than 0.05. And this leads us to fail to reject the null hypothesis.